Hello friends, welcome to my YouTube channel Obsession for Learning. Here I teach you step by step about design of structure manually and by using software. Okay, without doing delay, let's move to our topic. Today's our topic is about preliminary design of slab. Okay, here you guys can see a diagram which is about the residential buildings. Look at here guys, we have here 4 number of slabs. Okay, 1, 2, 3, 4, having 4500 mm by 4500 mm size each, and these all the vertical elements which are columns. And look at the centers, there is one vertical elements which is also columns, but we can call it as a intermediate columns, and the columns which are at the corners we can call it as a edges columns. Okay, and the column which is present in between two corner columns or two edges columns we can call it as a face columns. Okay, the height of the structure is 300 mm, the length 4500 mm plus 4500 mm, and width is 4500 mm plus 4500 mm. Look at this, these are the grid lines, and A, B, C, these grid lines we can call as a alphabetical grid lines, and 1, 2, 3, these grid lines we can call as a numeric grid lines. Okay, now our today's topic is preliminary design of slabs. For that, here we have one slab ID 1 to BC. Okay, 1, 2 and BC, these four grid lines represent these slabs. Okay, and today we are going to design these slabs. For these slabs, here we have length along x-axis which is represented by Lx, and also we can call it as a shorter span which is 4500 mm. Length along y-axis which is represented by Ly, and also we can call it as a longer span which is 4500 mm. For the first step, what we have to do is we have to check for one-way slabs or two-way slabs. For that, we have to calculate the ratio Ly by Lx. Ly represent the longer spans, Lx represent the shorter spans. It means the ratio of longer span to the shorter spans. But in our case, Lx and Ly is equals. Okay, that's why we're getting here 1 by calculating this value which is less than 2. So our slab is two-way slab. Okay, for step number 2, we have to calculate the effective depth of the slabs. For that, we have to take shorter spans, okay, not the longer spans, which is represented by Lx, and in our case the shorter spans is 4500 mm, right? And grade of concrete which is M25. For M25, the compressive strength of the concrete is 25 Newton per mm squares, and grade of steel which is Fe500, and the L stress for Fe500 is 500 Newton per mm squares. Look at here, but here I'm assuming percentage of tension steels is equal to 0.4 percentage. Remember guys, I'm assuming tension steels, not the compression steels, right? And these relations from the deflection criteria as per IS 456 2000 class 23.2.1. Actually I'm doing preliminary designs of slabs as per IS 456 2000. Okay, and D is greater or equal to Lx by alpha, beta, gamma, delta, lambda. These relations from deflection criteria. Okay, here's alpha, which is basic value, is 26 per continuous slabs. Look at it guys, as per IS 456 2000 class 23.2.1 8.a, basic values of spans to effective depth ratios for spans up to 10 meters. The basic value is 26 for continuous beams. Okay, and beta is equal to 1 for spans up to 10 meter, but we have here 45 100 mm, it means 4.5 meters, so it is under the 10 meters, so we can take the beta as 1. Okay, for gamma, what we have to do is, okay, we have assumed here 0.4% tensions reinforcement, right? And for gamma, what we have to do is we have to calculate the Fu, which is still stress of service load in Newton mm squares. And for calculating Fu, we have here formula 0.58 into Fy into area of cross section of steel required divided by area of cross sections of steel provided. Here what am I doing is I have assumed here the ratio of these two area as ones, and we have Fy, L stress of steel is 500. So if we multiply 0.58 into 500, we're gonna get here 290. So we're getting 290, right? For Fs is equal to 290, and percentage of steels of tension reinforcement 0.4. If I extend line from 0.4 percentage of tension reinforcement towards the upward directions, it meets at these points on this curve which have value Fs is equal to 290. So on this point, so now what I have to do is I have to draw horizontal lines toward the left side from here, so like that. So this is the value for gamma, or we can say the modification factors. Okay, now for delta assumes no compression steels. It means, okay, we have here 0% of compression steels. So for 0% of compression steels, the modification factor is 1. Similarly, lambda is equal to 1 for no wave. It means we have here, actually I have assumed ratio of wave width to the flange width as 1. So for ones of that ratio, the reduction factor also 1s. Okay, by putting this value on this relation, we are getting here 153.165 mm, which is greater than 150 mm. It means we have to provide the secondary beams. Now we have to divide the slab into equal slabs. For that, what we have to do is, look at here guys, actually this is our longer spans. Okay, so we have to divide these spans into equal parts, and we have to divide the whole entire slab into slabs by providing the secondary beams in between these two slabs. And what actually happens, our previous shorter spans, it becomes the longer spans. Our new dimension of divided slab, it becomes shorter spans. Look at here. Okay, Lx primes, it is a new dimension of divided slabs, which is the half of longer spans. By calculating this value, we're getting here 20, 250 mm, okay, which is less than 4500 mm. The previous shorter spans, it was 4500 mm. Okay, now what we have to do is we have to calculate against effective depth of the slabs for new slabs. Okay, and only the value of Lx primes is changed, the rest of the value is remaining same. So by replacing the Lx prime value, or by putting the Lx prime values, we're calculating here, and we're getting 76.58 mm. For providing more safety, I'm taking here 125 mm, which is less than 150 mm, so hence it is okay. Now provide depth of slab 125 mm and cover as 20 mm, so overall depth is equal to 125 plus 20. By adding these two value, I'm getting here 145 mm. Okay, that's all. Actually the main purpose of preliminary designs of slab is just to find out the thickness of slabs, and on the base of preliminary designs we do final designs. Okay, that's all for today. I hope this video is helping you guys. If it's really helping, please don't forget to give thumbs up, subscribe my channel, hit the bell icon for getting notifications. And at last, if you guys have any confusion and difficulty, please leave comment in the comment sections. I will try to make video according to your comments. Okay, thank you so much for watching my video. Take care and bye bye.